Hello students, today's agenda is to check homework. We will be learning about proofs for parallelograms, rhombi, and isosceles triangles, and you will be able to work on 11.7. Today, students will be able to prove theorems involving parallelograms, rhombi, and isosceles triangles using variable coordinates. Okay, so we're going to start with a small warm-up. And it says, find the missing coordinates. So this is a review of what we saw before. And it's just to make sure that we understand what we saw in, I believe it was the first lesson for this unit. So I want to ask you, if this is the y-axis, and this is the x-axis. If you want to try it, you're trying to find the point for A and D, so make sure you pause the video and then go ahead and continue with the video. But if these are the axes, this point D, is exactly at the origin. So the coordinate is going to be 0, 0. Now, how can we know the distance of this side? Well, since this is x, that means that this measurement is in here is a certain distance that we don't know, but is defined by the variable a. Okay, so it can be 8 units, 4 units. We don't know what the variable, the number or the value of that a is, but we know that that's the measurement from here to here. Okay, why? Because this is the x coordinate, and then it doesn't go up or down. That's why for y we have 0. To get to this point, we have a plus b for the x. Okay, so for the x is a plus b. That means that we had to get to this point on x, we had to go, basically you go on x and then you go up on y, correct? So this says that it's x plus b. So if this is a, then b is going to be this small section right here. Assuming that this is a parallelogram, parallelograms have the same tilt, so that means that this distance right here is the same as the distance in here. So my coordinate for x is going to be, so how far do I move on to get to this point? Well, is this much on x, and we already said that that much is the same as this measurement, right? So it's going to be b for x in this point, and for y is going to be, well, to get to this point on y it was this much. Let me get the green one. For it was, you go up this much, and guess what? For this point you also go up the same amount. So if this is c for y, then in here, since it's the same measurement, then you go up the same amount, so it's also c in that case. Okay, again, how do we know that this is b, that we would use the measurement b? Because in here they're giving us that x for b, the x is a plus b, so that means a plus a little bit more, which is they call b. So since that same amount is the same amount in here, that means that x in here you have to go b, and then c is because it goes up the same amount, and it's positive for both because both go up. Okay, so I hope this helps for the review. And now let's go to the lesson. So it says, prove that the sides of the isosceles triangle below are congruent. So let's look at the information in here first. This point is 0, 0, and it's basically because it doesn't go to the right or up, and so it's at the origin. This point goes a and b, so basically they're calling a up to this point and then B up. Okay, this is B. So since it goes the same amount in here, so instead of A, it's gonna be 2A for X. Okay, so 1 times A and then the same amount, the same measurement, so it's twice A. And then 0 because it doesn't go up or down on Y. Okay, so now it says that the sides of the isosceles triangle below are congruent. Congruent is the key word here. And I'm just gonna, on the side, I'm going to write a very small summary of what we've been seeing the previous lessons. So when you say congruent, remember that it means the same measurement. That means the same distance. So you're going to use the distance formula. And the distance formula is D is equals to the square root of y2 minus y1 square plus x2 minus x1. Okay, so we'll go back to that. I just want you to see the summary. So anytime you see the word congruent, it means distance formula, so that's what you would use. And you also have to check what is it that they're asking. If the sides are congruent, or sometimes you have diagonals, okay? So that's another important part of it. Okay, so congruent, now if they say perpendicular, and perpendicular means that they form a right angle. So something like that, and it can be two sides being perpendicular, or if they're talking about the diagonals, whether these are perpendicular or not, okay? Again, sometimes, in some cases, the diagonals refers to the inside lines. So those are diagonals, sometimes they are perpendicular. Okay, and I'm gonna give you a list later on of all the characteristics. Right now we're just coming up with proofs, but later on we'll come up with the summary. Okay, perpendicular. For perpendicular, you have to look at the slope. And remember, the slope has to be, they have to be opposite, reciprocal. Opposite means the opposite sign. Okay, opposite sign. And reciprocal means switch. You switch the numerator and denominator. Okay, and the formula for this will be m is equals to y2 minus y1 over x2 minus x1. Okay, and finally, perpendicular. Finally, the other key word is bisect. Bisect means that they cut into two equal parts. Cut into two equal parts. And what you need here is the midpoint. If they are cutting themselves in half, then that means that they share the same midpoint. And the formula for the midpoint is m, and then x1 plus x2 divided by 2, y1 plus y2 divided by 2. Okay, I'm thinking of the slope, that's why. Okay, so for the midpoint, it's going to be x1 plus x2 divided by 2, and y1 1 plus y2 divided by 2. Okay, so these are the three formulas. Again, these are the keywords of what they're asking for, but then you also have to look at, is it talking about the sides or is it talking about the diagonals? Okay, very important. Okay, so it says prove that the sides of the triangle, the isosceles triangle below, are congruent. So we're going to look at, well, you already know that two sides are congruent. You can try with the third one and see that only two of them are congruent. So when it says congruent, you already saw that it's talking about the distance. So let's do distance AB. And so it's going to be D is equals to square root of y2 minus y1 square plus x2 minus x1 square. And so I'm going to put here the 2 points. So point A is 0, 0. Point B is A, B. And so in here, we're going to be able to substitute. So y2 minus y1, so remember, you just subtract that. So this is x1, y1, x2, y2. So it's going to be y2 is AB minus 0 square plus x2 is A minus from the formula 0 and then square. And so we take the square root of B minus 0 is B square plus A minus 0 is A square. And if you want to, you can get it out of the parentheses, so it would be B squared plus A squared. Now this will be the answer. You cannot simplify anymore because it has the plus in there. And so that will be the distance of this side. Okay? Now let's do side BC. So the distance is the same formula. I'm not gonna rewrite it. I'm just gonna apply it. So y2 minus y1. And so the point B is AB. Point C is 2A 0. And so it's gonna be y2 minus y1, so the last one and the last one, 0 minus b squared plus 2a minus a squared. Remember that if you get confused, you might want to label them x1, y1, x2, y2. Okay, and that way you know where each one goes. And so to simplify it, I'm just going to use this one in all blue. So it's going to be 0 minus b is negative b squared plus 2a minus a is a squared. If you have 2a and you're subtracting 1a, then that's equals to 1a. And so this gives me negative b times negative b equals positive b squared. Positive a times positive a is a squared. And you can see that those two sides are congruent. Now let's look at the last side. So that would be side AC. And the distance is equals to, again, we take the square root of the addition of the squares of the differences. What? And so, again, let's write the point A is 0, 0, the coordinates of both. Point C is 2A, 0. And we can just 0 minus 0, and then 2a minus 0. Okay, so it's going to be 0 minus y1 is 0, x2 is 2a, x1 is 0. Okay, and so in here we get 0 minus 0 squared is just 0 squared, which is going to disappear basically. And we have 2a minus 0 is 2a. We have to put it between parentheses because the square in here refers to both, not only the a. And so 2a times 2a becomes 4a squared. And I'm going to do it on the side. So 2a squared means 2a times 2a. 2 times 2, 4. A times a squared. Okay? And the square root of that is going to be, the square root of 4 is 2. The square root of a squared is a. So this is the answer for the third side. So you can notice that the third side is not the same as the first two sides that we did. So in an isosceles triangle, only two sides are congruent, and this is the proof. Okay? Okay, let's do a different exercise. Remember, congruent, that means they have the same measurement, the same distance, so you're using the distance formula. Okay, now in here, we're looking at, it says prove that the diagonals, now it's talking about the diagonals of the parallelogram are not perpendicular. So that means that they do not form right angles. And if they were to form right angles, then they would have the opposite and reciprocal. So opposite sign, if one is positive, the other one has to be negative. And the numerator and denominator should be switched. Okay, so to begin with, diagonals refers to these lines right here, these line segments. That's a diagonal, and this is another diagonal. Okay, and so we're looking for, if it says perpendicular, that means that it's related to the slope, which is m equals y2 minus y1 over x2 minus x1. Okay, and so we're gonna find the slope of that one and the slope of that one. If they were perpendicular, that means that, again, one is positive, the other one is negative, and one is numerator, denominator, and they switch for the second one. Okay, so let's begin with AD. So the slope for AD, we're going to use that formula, y2 minus y1 over x2 minus x1. So I'm going to put the coordinates in here, and then D is C0. And then y2 minus y1, so these two, okay? And then x2 minus x1, these two. And so that's 0 minus B over C minus A. And so if you need to, you can go ahead and, instead of using the arrows, you can use x1, y1, x2, y2. And so 0 minus B is equals to negative B over C minus A. We cannot combine them because it's two different variables. We just rewrite it the way it is. And so that's it. That's the slope for AD. Now, sorry about that. Now let's look for the slope of CB. CB. And so the slope is equals to, again, letter C, point C is 0, 0. And point B is located at A plus C, that's my X, and B is my Y. Okay, so y2 minus y1 over x2 minus x1. And so it's going to be B minus, from the formula, 0 over A plus C, which is my x2, minus from the formula, and then 0. And so B minus 0 becomes B. A plus 0, A plus C minus 0. So basically that doesn't affect. So it's just A plus C. So this is the slope of the other diagonal. Now, are they opposite reciprocal? Let's see, opposite and reciprocal. Well, you can say somehow that this is negative and this is positive, but also is it reciprocal? Does the b become or go to the denominator, and the c minus a, does it go up to the numerator? No, we have b for both on top and then ac at the bottom. So no, it's not reciprocal. Somehow we can say that it's one is positive, one negative, but it has to have both components. So we're gonna say no, they are not perpendicular because negative b over ca is not reciprocal to, let's see, do I have more space in here? Maybe I was, because negative b over c minus a and b over a plus c are not opposite reciprocal. Okay, and so that's the explanation. They're not perpendicular because they're not reciprocal. Okay, that part does not fulfill. And so this is the explanation for 11.7, and now you can go ahead and have fun doing that.